Very good morning, students. In the last lecture, we have seen the perpendicular axis theorem. In this lecture, we are going to state and prove the parallel axis theorem. Students, before going to what the statement or before understanding the statement, let us understand the first diagram. Students, what we observe? This is a rigid body. Rigid body is rotating about an axis passing through what? O. Students, we have to find the moment of inertia of the rigid body about that axis. Students, as you know, already I taught you the definition of center of mass. The point where entire mass of the object is what? Concentrated. Students, here point C is the center of mass. An axis passing through a center of mass and moment of inertia of the body about center of mass is given by IC. The students, it states that moment of inertia of the body about any axis is always equals to moment of inertia of the body about its center of mass plus product of, students, product of mass of the body and distance between two axes. Students, what is here? Axis of rotation. We have to find IO and IC already given inside center of mass. And what distance between IO and IC is what? H. So let us again read that particular statement. The moment of inertia IO of an object about any axis is the sum of its moment of inertia IC about an axis parallel to the given axis and parallel passing through the center of mass. Students, the condition is what? Both the axes should be parallel. That's why this particular theorem is called parallel axis theorem. Okay. So now let us complete the statement. And the product of mass of the object, you can see here, I already have written product of the mass of the object and the square of the distance between the two axes. Square of the distance between the two axes, that is mh square. Okay, so you understood the statement. Now let us prove. Students, for that, as I told you in the perpendicular axis theorem, it is difficult to find out the moment of inertia of the rigid body of irregular shape. So I am going to consider small point whose mass is what? dn. That point is what? d. So students, we have drawn dn perpendicular to what? You can see here dn I draw perpendicular. If I extend this OC further, so dn and OC meets at point N. Students, what is the distance of that particular point from this particular axis which is passing through O is what? OD. And what is the distance of this particular point from this axis of rotation which is passing through center of mass is what? CD. So students, let us find out the moment of inertia of what? The particle which is at a distance of OD. So students, moment of inertia of this particular particle about an axis passing through O is given by integration of mass into distance square. What is distance square, students, here? OD square. Similarly, we can find the moment of inertia of the point of the particle about a center of mass is given by not integration, sorry students, integration I am going to put afterwards when I find out IO. If I found out IO, that time I will put the integration of what? dn OD square. Here also I am not going to put integration first. dm into what? What is the distance of the particle from the center of mass is what? CD, the square. Then I will take the integration to find what? Moment of inertia of the body. This IC and IO represent moment of inertia of the body about an axis passing through point O and passing through center of mass. That time I will take the integration. Okay, students. Now, students, let us do the simple mathematics over here. We observe that OD square, OD is a what? Hypotenuse of this right angle triangle, ODN. So here I am going to apply the Pythagoras theorem. So students, what is OD square equals to? ON square plus DN square. ON square plus what? DN square. Integration dn. Students, what is ON? ON is a sum of OC plus CN. OC plus CN the whole square plus what DN square. Students, here I am going to apply A plus B the whole square. So I already applied over here. You can see what A OC square plus twice of OC into CN plus CN square plus what, students? DN square, bracket close, DN. Students, what is CN square plus DN square? We observe here CN square plus DN square is what, your CD square. According to Pythagoras theorem, since CD square equals to what? Cn square plus Dn square. In place of Cn square and Dn square, I will write what? CD square. Okay, according to Pythagoras theorem. Initial terms I will write as it is, OC square plus 2OC into what? Cn plus. Students, let us continue simple mathematics. What is OC, students? OC is the distance between two parallel axes whose distance is what? H. So in place of OC square, I will write what? H square. In place of OC, I will write what? H. Cn I kept as it is, and CD you can write DC also. Okay. Then I'm going to shift integration sign inside to integration of, first let me write DC square along with the DM square. DC square into DM plus, then I will write here 2H integration of dm into cn plus integration of what? dm. H square is what? Constant, that's the distance. That's why I took what? Outside. Students, this particular term you already proved here, that is what IC. So here I am going to replace this particular term by what? IC plus x square. And what is integration of small particle? Integration of dm is what? Capital M. We know that integration of x is what? Sorry, integration of dx is what? X. So integration of dm is what? Capital M. Students, now this particular term is what? 0. For that you have to write down Cn is the distance of the point D from the center. You can see Cn is the distance, perpendicular distance of the point D from what? C. So as I know, from the center of mass, every particle is what? Distributed symmetrically. The mass distribution is what? Symmetrical. That's why if I take the integration of dm and cn, the mass distribution is symmetrical about center of mass. That's why its particular value, integration of dm into cn, integration of dm into cn is always 0. That's the final answer is what, students? As I told you, integration of cn into dm is 0. So IO equals to what? IC plus MX. Hope so you understood the parallel axis theorem. Thank you very much.